So let's review some more things about graphs from last year in polynomials. We talked about even degree polynomials that have a positive leading coefficient, and that they're in behavior. We didn't use the word in behavior, but we said that the left side goes up and the right side goes up. Remember, even, equal, they do the same thing. So now we know our notation for in behavior. So the limit as x goes to negative infinity, f of x goes up forever, positive infinity. And the limit as x approaches positive infinity of f of x is also positive infinity. If instead I do it even negative, that means both ends of my graph, the in behavior, goes down. So the limit as x approaches negative infinity of f of x equals negative infinity. And the limit as x approaches positive infinity of f of x equals negative infinity. Odd is opposite. So if it's a positive leading coefficient, that means overall from left to right we're going up. So what is my left side doing? The limit as x approaches negative infinity of f of x, left side goes down. But if the left side goes down with odd, that means the right side is going up to positive infinity. Then we have odd degree negative leading coefficient. That means my left hand is going up. So as x approaches negative infinity, we're going to positive infinity. And as x goes to positive infinity, f of x is going down. So if we look at that, I'm going to circle where our negatives are and our positives. So even is equal. They do the same thing. So I'm both positive or both negative. Odd, they're opposite. One's going to be negative, one's positive. And I talked about doing this like a dance, and so odd tells you what the right hand is doing. So odd positive means your right hand is going up. Odd negative means my right hand is going down. And then I know the left side does the opposite. The other key topic we talked about with graphs is multiplicity. So multiplicity has to do with the number of occurrences of a specific zero. And it corresponds to the exponent on that factor once we have a factored form of my equation. And it affects the shape of the graph around the x-intercept. So just if I zoom in at the x-intercept, what does that shape look like? So if we have a single zero, that means it's a multiplicity of 1. It's going to just straight up pass through my x-axis at that point. If it's a double zero, so multiplicity of 2, it's going to look like a little parabola. It's going to bounce right at that 0. And if it's triple, that means as an exponent of 3, it's going to get flat and cross right at this the x-intercept. So if it's even, then that means when we're doing a sign chart, which we'll review in a second, that my sign chart is going to stay the same sign. So plus, plus, minus, minus. And the graph is going to touch and bounce the x-axis at that 0. If it's an odd multiplicity, the sign chart is going to change and it's going to cross through the x-axis at that 0. The larger the multiplicity, the flatter the graph is at that 0. So if I'm to the 4th power, that means it's going to look like something to the 2nd power, but flatter. And if I have the 5th, it's the same as the 3rd, but flatter right at the 0. And the total degree of the function is equal to the sum of the multiplicities of the zeros. So if I just write a little random thing right here, we can find our degree. So 3 plus 2 is 5, plus 4 is 9, plus 4 is 13, as long as I can add today.